All right, welcome back. Today we are moving on to section 1.3. We are going to talk about units and dimensions for our class. This is a very important topic. Please, please, please take this topic serious because you will get problems wrong if you do not give me correct dimensions, okay? Or units, excuse me, and same thing. In this class, we will be measuring three different types of quantities. We are going to measure length, we are going to measure mass. Notice I did not say weight. They are very different from one another. Mass and time. So I'm pretty sure that all of you know what a length is, what a mass is, and what time is. And so I'm sure we can do a lot with those together. Okay. All other quantities that we deal with in this class, like force or joule, is some combination that can be constructed from those three. Okay. So that's a kind of simple, hopefully that makes you feel more confident. We're only using three different quantities, but they're going to get combined to mean different things. So we're going to use the SI units, the standard, the International Standard of Units is considered the SI units. And this is the base unit for a meter. I'm sorry, length. It will be a meter, okay? The base unit for mass is kilogram, and the base unit for time is second. And what do I mean by this base unit? That means every single time somebody gives you a length and a problem in feet, what do you need to convert it to first? Meters. If you are given a mass in grams, what do you need to convert it to? Kilograms. If you do not go back to our base, then a lot of the equations, your units, when you have to combine them to, for example, force, it won't be right. You'll be incorrect. You'll be off by some factor because you didn't convert your units. So length, let's just reiterate, length always in meters. I'm going to write this out. Mass always in kilograms. If it's in something else, you need to convert it to kilograms. Time, always. If it's in hours, what do you convert it to? Seconds. If it's in minutes, convert it to seconds, okay? Okay, that's what we're going to work with in the entire year. Will there be times when you're giving a unit or a measurement that's not in those? Yes. What do you need to do? Convert. Well, how do we convert? Well, one of the things you need to know are these common unit prefixes that are used throughout the SI units. That's actually one of the beauty of SI units. We can have these prefixes that we can move back and forth quickly for. And you have seen quite a few of them: milli, centi, deci, kilo, so kilogram, milligram, centimeter. Okay, so how do I use this chart? I can use this chart to come up with conversion factors. So if I come over here and I get told, well, how much, I want to look at kilogram. So I look at kilo and I find that 1 kilogram is equal to, well, the prefix kilo is equal to 10 to the third. And sure enough, 1 kilogram is equal to 10 to the third. What? Grams. Okay. Well, what about kilometers? Same thing. If kilo is 10 to the third, whether I'm in grams or meters, I can find that 1 kilometer is 10 to the third meters. That's the beauty of it, okay? Whether it's grams or meters. But what about millimeters? Well, let's go to millimeters. So if I go to millimeters, I see that 1 millimeter is 10 to the third meters. So I go back to the base unit meters, okay? So let's use this knowledge that we have just learned and do a problem. What is the length in meters of an E. coli bacterium that has 0.005 millimeters, and I want it in meters, okay? So I want to convert that to meters. So I have 0.005. I'm going to teach you how to use a technique that I was taught my first year in college, and I wish I would have been taught it sooner, and I hope that you catch on to this. I think some of you have had me sub before, and I always use this method when I do conversions, and actually when I solve any problem, because I'm always checking my units. Units are telling me whether or not my problem's right or wrong. Okay, so I have millimeters. I need to get rid of millimeters because I want my answer, and I just have a whole bunch of little squares here. I don't know how many spots I need, but it doesn't matter. I want my answer in meters. I need to have my answer in meters. So everything on the left-hand side has to cancel out all my units to make one left on the top, meters. Okay, so I need meters, millimeters to go to meters. So let's go up and use our chart. And if I look at this chart, I see that 1 millimeter is equal to 10 to the minus 3 meters. Okay, all right, so I can then, what does that mean? 1 millimeter is equal, that means, you know, if they're equal to one another, if I divide them by each other, what's the value? 1, right? Well, I could multiply that 1 times anything, and I don't change the value, I just change the unit. So anyway, I want meters to go away, right? I'm going to use that conversion factor and help meters go away. So I'm going to put millimeters. I want millimeters to go away. So millimeters, I need to be on the bottom, and on top, I'm going to use this 10 to the minus 3 meters. And so now I'm going to go through and I'm going to cancel out my units, and there is only 1 unit left, and it is meters. And that is exactly what my answer needs to be in. And if I were to actually plug that into my calculator, I would find that I get 0.00000. Let's see if I counted all those right. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yep, and that is equal to 5 times 10 to the minus 6 meters in scientific notation. Okay, so please keep track of your units. I am always going to use this technique, and I hope that you also start. If you learn how to do that, you're going to make yourself, you will get more problems correct. All right, how can we do this quickly using a common acronym? You guys have heard this before, and I'm actually going to spend time reminding you. King Henry died drinking chocolate milk, and this blank could be a gram, a meter, a second. A gram, a meter, a second. And so I want you to visualize a decimal point after each one of these things, right? You've used this before, and so we know that if I want to go from, say, millimeters to grams, I start from the milk and I start counting to the left how many times do I have to move the decimal point. So let's do some problems. Let's see, 1,000 grams equals how many kilograms? Well, if I have King Henry died and I'm at the gram location, I need to go 1, 2, 3. I have to move my decimal point 3 times. So I take my 1,000 and I take my decimal point and I move it 3 times, and I find that that equals 1 kilogram. If I have 10 milliseconds, King Henry died, my base unit, drinking chocolate milk. Whoops, I don't know how to write it in, evidently. Milk, I have my decimal point after the milk, and I'm going to move to the second location, which is right here, and I'm going to go 1, 2, 3. I got to move the decimal point 3 times to the left. So I take 10 and I go 1, 2, and I got to go 3, and I got to put an extra 0 in. So 0.010 is the answer. Okay, I hope that makes sense. Oops. Okay, keep going, moving forward. Okay, 10 centimeters all the way to kilometers. So King Henry died at my base unit drinking chocolate milk. All right, so here's my centimeter decimal point. I want to go all the way to kilometers, which is all the way over here. So how many times do I have to move it? 1, 2, 3, 4, 5. I've got to move the decimal point 4 times. I'm sorry, 5 times. Hard to talk and write at the same time. So 1, 2. All right, now I got to put a 0 in. That's 3. I got to put another 0 in. That's 4, and that's 5. So the answer is 0.0001. Okay, the next problem is letter D. If I have 10 to the minus 3 millimeters, how many kilometers is that? King Henry died drinking chocolate milk. How many times do I have to move that decimal point? 1, 2, 3, 4, 5. Nope, should be 6. I'm counted wrong. 1, 2, 3. I forgot one. 1. Okay, let's try that again. Okay, how many times I have to move the decimal point? Don't forget this decimal point right here. That's always what I do. Okay, 1, 2, 3, 4, 5, 6. There's 6 times to the left. That's a negative 6, right? Well, guess what? You can just take that 10 to the minus 3 and add negative 6 to it, and you get 10 to the minus 9. Makes life a lot easier that way. Okay, or you can do it by hand. It's okay. Next, dimensional analysis. What does that mean? Okay, what does dimensional analysis mean? It is extremely, extremely important to pay attention to units. Your answer is incorrect if your units are incorrect, okay, in this class, okay? And I'm gonna do you a favor. It's gonna be a struggle at first because maybe your teachers in the past haven't been super diligent about that, but I'm gonna tell you, your answer is wrong if your units are wrong. Please put that in your head. So here's one thing I want to tell you. If you actually do a calculation and you look at your units, okay, and you find that your units are wrong, okay, the units came out wrong. If you're trying to measure something, you know that it should come out in the units of meters, and you find that the answer is in meters squared, guess what you know for a fact, without a doubt? You are 100% confident that you are what? Wrong. Okay, so go back and figure out what equation you did. Did you use the wrong equation? Did you do a math error? If you find your units are wrong, you know you are incorrect, and you might as well go back, or else you're not gonna get the points right. If you find that they are correct, the units are correct. Guess what? You have a chance at being correct. You have a pretty good chance. You don't know for sure, but at least you know that you have a decent chance of being correct. So so anyway, whoops, what happened here? Okay, all right. So continuing on, dimensional consistency using dimensional analysis means that each term in a physics equation must have the same dimensions. Okay, what do I mean by that? You can't add apples and oranges. Okay, so if you're given this equation, this is an actual common physics equation here. This equation right here, x final is equal to x initial plus velocity times time. And you know that x final is a measurement of length. This velocity, which is meters per second, the second has to cancel. I can't add meters plus meters over seconds, okay? You just can't. So you have to have what I call dimensional consistency. So let's do a quick problem. These are straightforward problems. So I have a warehouse that has a length of 1980 centimeters, and it has three sides basically. I don't remember which side's what. And then I have one that is 495. I may not have done that properly, but here we go. I want to know the volume. What's volume? Volume is height times length times width. Okay, so I will take 1980 centimeters times 1050 centimeters times 495 centimeters. And what's a volume? Volume is a cubic centimeter, cubic meter. So I'm going to have cubic centimeters as my answer. They didn't want cubic centimeters as an answer. What did they tell me they wanted it in? Meters cubed. Well, how many centimeters are in a meter? King Henry died drinking chocolate milk. I have to move the decimal point one time. I know that 100 centimeters is equal to 1 meter. So I can come over here and write 100 centimeters and put 1 meter on top, right? How many centimeters did I cancel? I only canceled 1. Well, how many centimeters do I have on top? Well, I have 3. So I have to have 3 on the bottom. I only have 1. So I could actually write out 1 over 100 3 times, which would be kind of a lot of work. Or I could do this. What if I cubed it? Now I have centimeters cubed. So I have 3 on the bottom and I have 3 on the top. But what do I have to do with that 100? I actually have to cube it. So I can do this problem all in one step and not actually convert everything individually, even though that's what they did in the book. I think that's, once you get more confident, you can do it all at once. All right, so there's your answer. So why don't you practice doing these problems here on your own and see if you get the correct answer. Number 13, I will tell you is, the answer is for number 13, 624 meters cubed. That's what I got. Check my work. Miss Query sometimes does make mistakes, trust me. You will catch me, trust me. All right, number 14, I got 1,200 mils. Okay, see if you get those. If you don't, let me know. And if you have a question, please message me. Have a great day.